students, in this video today I am going to explain numerical problems from current electricity. The questions already I have written on the board. See that. Question number 1. Find the equivalent resistance between points C and D in this figure and also between the points A and B. Now, see that R2, R3 and R4, these three resistors are in series. So, R2, R3 and R4 are in series. So, I can say that the equivalent resistance Rs is equal to R2 plus R3 plus R4. This is equal to, all are 3 ohms given. So 3 plus 3 plus 3, that is equal to 9 ohm. Again, this Rs and R5 are in parallel between points C and D. C and D. So I can say that this is in parallel combination. So the equivalent resistance in parallel combination is equal to this total 1 upon R5 is equal to 1 divided by 9 plus 1 divided by 3. LCM I have taken 9. 9 plus 3 is equal to 12 divided by 9, or I can say that 3, 3, 3, 4. So implies that this Rp is equal to 3 upon 4. So this is equal to 0.75 ohm. Now we got the Rp is equal to 0.75 ohm. That means the equivalent resistance between C and D, the equivalent resistance between C and D is 0.75 ohm. Now, listen carefully. Now, again R1, this Rp and R6 are in series. So, now I can write that. Now, R1, Rp and R5 are in series. So total equivalent resistance equal to R1 plus Rp plus R6 is equal to 3 plus 0.75 plus 3 is equal to 6.75 ohm. So I can say this is the equivalent resistance between A and B. A and B is 6.75 ohm. Is it clear? Once again I am explaining. You see that find the equivalent resistance between C and D and A and B. See this circuit, in this circuit. So R2, R3 and R4 are 3 in series. So in series combination, total resistance is equal to sum of the resistance. So I have written that R2 plus R3 plus R4, each one 3 ohm. I have written here 9 ohm. At the same time, now this equivalent resistance is parallel with the resistance R5. Rs and R5 are in parallel between C and D. So if I take equivalent resistance due to parallel combination, this is 1 by Rs plus 1 by R5. I mentioned here 1 divided by 9 plus 1 by 3, which is equal to 12 by 9, or you can say that 4 by 3. So implies that this Rp is equal to 3 by 4, which is equal to 0.75 ohm. This is the equivalent resistance between the point C and D. Now again, resistance R1, this equivalent resistance Rp and R6, these 3 are in series. So simply to get the equivalent resistance, I have added these 3. So as a result, I got 6.65 ohm. So the equivalent resistance between A and B is 6.75 ohm. Clear, children? So now let us move to the second question. The second question is very important question. So far as your board exam is concerned, listen carefully. It is mentioned that in this figure, calculate the current and potential difference across R1, R2 and R3. In this circuit, 3 resistors are connected. The resistances are given 6.0, 6 ohm, 4 ohm. It is connected with a battery of 4.2 volt. Calculate the current and potential difference across R1, R2 and R3 where K1 and K2 both are closed. First condition. Second one, K1 is closed, K2 is open. K1 is closed, K2 is open. Third case, K1 is open and K2 is closed. So listen carefully. First question is that when K1, K2 both are closed. So the condition what is that K1 and K2 are closed. If K1, K2 both are closed, that means now the current will flow through this circuit. So at first I want to calculate the total resistance. Here R2 and R3 both are connected in parallel. So I can say that R2 and R3 are connected in parallel. So the equivalent resistance we can calculate by using this formula 1 upon R2 plus 1 upon R3. I can write this is 1 divided by 6 plus 1 divided by 4. So LCM is 6, sorry, 12. So 2 plus 3, this is equal to 5 divided by 12. Implies that this equivalent resistance due to parallel combination is equal to 12 divided by 5 is equal to 5 to 10 to 0.54. That means equivalent resistance is 2.4 ohm when these two are connected in parallel. But with this total resistance, this resistance connected in series. So I can say that total resistance writing RS is equal to R1 plus RP, because this total and this one both are connected. You can say this series R1 plus RP. So R1 is 6, RP is given 2.4, this is equal to 8.4 ohm. Total resistance, or you can say total equivalent resistance in the circuit. Now we have to calculate the total current. So I can say that total current I is equal to, according to Ohm's law, V equal to IR or I equal to V by R. So I can write that I is equal to V by R. This total resistance I have taken RS. So this is V divided by RS. Here V is given 4.2. RS we got, this is the 8.4. So this is 1 divided by 2 or equal to 0.5 ampere. This is the total current. The question is that calculate the current and potential difference across all these three resistors R1, R2 and R3. But we got the total current. Now listen carefully. Current through R1, this is equal to total current, or you can say that is equal, this is equal to I1. So already you know total current is equal to 0.5 ampere. So when the current is flowing through this cell, through the R1, here the current, total current also equal to I1, means I equal to I1. I can write this is equal to 0.5 ampere. This is the current through the R1. What about the potential difference across R1? So I can say that potential difference across R1. So according to Ohm's law, V equal to IR, or I can write R equal to V by I, or I can write this is equal to across R1. According to Ohm's law, potential difference is the product of current and resistance. So I can say that here the potential difference is I1 R1. Here I1 is given 0.5 and R1 is given 6. That means this is 3 ohm. Potential difference across R1. Second fact is that here R2 and R3 both are connected in parallel. So I can say that potential difference across both R2 and R3 is equal to 4.2 minus 3 is equal to 1.2 volt. So here one mistake is there. This is 3 volt. The SI unit of potential difference is volt. So we got potential difference across R2 and R3, that is equal to 1.2 volt. Since R2 and R3 are connected in parallel, so same potential difference across R3 if the resistors are in parallel, then the same potential difference maintained between its ends. So I can say that potential difference across R2 plus R3, that is also same for potential difference across R2 and R3, that is equal to 1.2 volt. So potential difference across the R1 we got, across R2 we got, and across R3. Now already we got the current through R1. Now we have to find out the current through R2 and R3. So current through R2, V equal to IR, I equal to V by R. So I can say that current through R2 is equal to R2. You can write this potential difference is equal to 1.2 volt. 1.2 volt. Resistance is 6. So I can write that this is 12 upon 60 0.2 ampere. Now the current through R3, current through R3, that is I3 is equal to V upon R3. This is equal to 1.2 upon R3, that is 4, is equal to 12 upon 40. Okay, so 4 is equal to 0.3 ampere. This is the current through R3. So the first one, the question was that calculate the current and potential difference across R1, R2 and R3. So already we did it, potential difference across R1, R2, R3 and also current through R1, R2 and R3. Now let us move to the second part, when K1 is closed and K2 is open. K1 is closed and K2 is open. When K1 is closed, K2 is open. That means K2 will not be in the circuit. K2 will not be in the circuit. That if K2 not in the circuit, that means R1 and R2 are in series. If R1 and R2 are in series, then I can say that RS is equal to R1 plus R2. This is equal to 6 plus 6. This is equal to 12 ohm. So we got the resistance is 12 ohm. What about the current? So I can say that current through R1 means I1, that is equal to current through R2, that means I2. Why I have written like this? The reason is that R1 and R2 are in series. So same current will flow through R1 as well as R2. That means I1 and I2 both will be equal. So this is voltage versus voltage divided by resistance. So I can say that here the voltage is given 4.2, resistance we got 12, this is equal to 42 upon 120, or I can write that 340 40, or you can say that this is 7 upon 20, or 3.5 upon 10, or that is 0.5 ampere. So we got the current through R1 and R2 both are equal, which is equal to 0.35 ampere. This is about the current. What about the potential difference? So potential difference across R1, that is V1 is equal to I1, R1 is equal to, we got I1 0.35 into R1 we got, that is 6, that means this is 2.1 volt. And similarly I can write V2 is equal to I2, R2, this is equal to 0.35 into R2 also given 6, this is also 2.1 volt. This is the potential difference between across R1 and R2. Since the resistance are equal, that's why the potential also equal. We got V1 2.1 volt, V2 also equal to 2.1 volt. So second one completed. Let us move to the third one. In third case, K1 is open and K2 is closed. If the K2 is closed but K1 is open, that means the circuit is open. There is no current. No current in the circuit. There is no potential difference between its ends. So this is about today's numerical problem. I hope you might have understood well. In the next video, some more new problems we will discuss. Thank you.